Instantaneous velocity. So instantaneous velocity is defined as the average velocity over an infinitesimally short time. So if we look at a curve, we can find the velocity at this point by drawing a tangent to the point and finding that slope. To do that, you take the first derivative of your position with respect to time. To take a derivative, you do the following. You take your exponent on your variable, for us it will be t, and you multiply it by the number that's in front of your variable. So we have n times c, and then you subtract 1 from your exponent. So for example, we have x equals at squared plus b. Our first derivative would be 2a times t, and the b goes away because there's no time involved. Our first example, we have a jet engine along a track, and its position as a function of time is x equals at squared plus b, where a is 2.1 meters per second squared and b is 2.8 meters. Determine the displacement from 3 seconds to 5 seconds. So displacement is your change in position, x2 minus x1. To find x1, you just plug in our a and our b and the time variable. So 2.1 times 3 squared plus your 2.8, your units do cancel, gives you 21.7 meters. Your x2 at 5 seconds squared, or at 5 seconds, you take your acceleration, 2.1 meters per second, times the second squared, plus 2.8. So remember the whole 5 is squared. You get 55.3 meters. Your change in position, 55.3 minus 21.7 gives you 33.6 meters. Determine the average velocity during this time interval. Average velocity is your change in position over change in time. So we find our delta x and divide it by delta t, which is 2 seconds in this example. Your average velocity is 16.8 meters per second. To use your new skill, we're going to calculate the instantaneous velocity at t equals 5 seconds. There's your original equation, and we're going to take the first derivative. The first derivative is 2 times 2.1 gives us 4.2t. The 2.8 goes away because there's no t involved. So our velocity at 5 seconds is 4.2 meters per second squared times 5 seconds. Our instantaneous velocity at 5 seconds is 21 meters per second. Our second example is about a particle, and its position is given by this equation. Now notice we have a cubed and we have just t here. X is in meters and t is in seconds. So a lot of times you won't see units in these type of equations. They're just known by what's given. So taking the first derivative, 7.8 drops out. This becomes 9.2. 3 times 2.1 gives us 6.3 t squared. Remember, you subtract 1 from your exponent. Plugging in our time, we get negative 6.8 meters per second, which just shows the direction, which usually means to the west or to the left. Part B asks, is the velocity constant or is it constantly changing? So what you need to do to answer that question is go back to your derivative of velocity. So velocity equals 9.2 minus 6.3 t squared. If t is still in that equation, it's going to change every time t changes. So our correct response would be, since v is dependent on t, on time, your velocity is constantly changing.